Mathematics is the science of structure, order, and relation that has evolved from elemental practices of counting, measuring, and describing the shape of objects. It deals with logical reasoning and quantitative calculation, and its development has involved an increasing degree of idealization and abstraction of its subject matter. I am Sir Phil na nagsasabing, palaging piliin mong matuto. Good day everyone, this is Sir Phil from Sir Phil's channel, and today we're going to discuss in our video lesson the joint and combined variation. So this is the part 2 of our discussion about the concept of variation. So let's start with the discussion of these last two types of variation, which are the joint and combined variation. Our objectives for this lesson is to translate mathematical statement to equations of variation and solve mathematical problems involving joint and combined variation, specifically the real-life-based situation which involves the joint and combined variation. Concept for this lesson are the following. Some physical relationships as in area, volume, speed, distance, and time may involve 3 or more variables simultaneously. So actually, the joint variation, halos kaparehas lang siya ng direct variation, and also sometimes they are using the same phrase, no? So, joint variation occurs when a quantity varies directly. So, varies directly pa rin siya as the product of 2 or more other quantities. So, pinagkaiba lang natin dito, more than 2 variables yung ginagamit natin. Unlike sa direct variation, those are the relationship lang of 2 variables. So, dito sa joint variation, gumagamit tayo, although this is also parang direct variation lang din siya, pero gumagamit ng more than 2 variables. So, for instance, if z is equal to kxy, where k is not equal to 0, then z varies jointly with x and y. So, in this particular type of variation, we're going to use the phrase varies jointly. Okay, so for us to say that it is a joint variation. So, the equation z is equal to kxy is the same with the statement z varies jointly with x and y. In terms naman of combined variation, it occurs when a quantity varies directly as the quotient of 2 or more quantities. For instance, so if the statement A varies jointly as B and C, means A is dito sa pag i-compare natin yung joint and combined variation. Kasi yung combined variation is the combination of direct and inverse variation. So, balikan natin ulit yung joint variation. Let's say for example here, A varies jointly as B and C. It means that A is equal to K BC. So, isang diretso lang siya na equation katulad ng direct variation. So, ang pinagkaiba niya lang is that gumagamit siya ng more than 2 variables. So, this is for the joint. Sa combined naman, it is a combination of direct and inverse or joint and inverse. So, more than 2 variables din to actually. So, let's say for example, the statement z varies directly as x and inversely as y. So, susundan lang natin yung unang variable na binanggit, which is z. So, this will be the one that is isolated equal to. So, laging kasunod na agad yung k no matter what. And this varies directly as x. So, kung direct lang siya, katabi siya ng constant. Tapos, meron tayong inversely as y. So, pag nagkaroon na tayo ng inverse dito, dun tayo mag-over, which is that is y. So, magiging ganun yung ating equation of variation because this is just a combination of direct and inverse variation. So, in terms naman sa pagkuha ng constant of variation, so, dito muna tayo sa joint. So, ang pagkuha niyan, i-divide lang natin both sides dun sa kasama ng K. So, that is B and C para maka-cancel to. So, yung pagkuha ng combined variation now, ng constant of variation, that is now K equal to A over BC. So, that is the variable that is isolated over yung dalawang kasama ng K. In terms naman of combined variation, sa pagkuha ng constant, cross-multiply muna natin itong dalawa. So, that will become ZY equal to KX. Tapos, syempre, constant yung kinukuha. Divide lang natin both sides dun sa kasama ng constant, which is X. So, makakancel na natin itong X. Ang matitira na lang is K equal to ZY over X. So, this is now our formula for the constant of variation. So, ito naman yung sa ating joint variation. Okay, so parang nagde-derive lang tayo ng mga formulas natin by applying the different properties of equality. Let's go over with writing equations given the relationships. So, always we use K as the constant of variation. So, let's start with the first one. So, the volume of a cylinder V varies jointly as its height, H, and the square of the radius R. So, meron tayong mga binigay na variable dito. So, gagamitin natin yan. For the volume, we have V. For the height, we have H. And for the radius, we have R. So, this is a joint variation because of this phrase, varies jointly. So, yung unang nabanggit na variable, V, varies jointly at its height and the square of the radius. So, constant muna and then yung height and then the radius. Tapos may binanggit dito na condition that it is a square of the radius. So, lagyan lang natin ng square. To get naman our constant of variation, that is equal to, although i-divide both sides lang natin yan sa HR squared, so that is equal to V. Yung naka-isolate natin over yung kasama ng K, kasi yun yung pandi-divide natin, HR squared. So that's how we write this statement into an equation. Next. The heat H produced by an electric lamp varies jointly as the resistance R and the square of the current I. So again, this is a joint variation. So sundin lang natin. We have the heat or H, yung unang nabanggit na variable, equal to K, varies jointly as the resistance R and the square of the current. So I squared. So, pag kukunin natin ang constant, that is K, equal to, so yung naka-isolate natin, H, over yung kasama ng K, Ri squared. Next. The force F applied to an object varies jointly as the mass, M, and the acceleration, A. So, in that manner, we have still varies jointly. So, this is a joint variation. So, we have F equal to constant as the mass and the acceleration. So, MA. Wala namang condition na iba. So, that is F is equal to KMA. And for our constant, K equal to yung naka-isolate, which is F, over yung kasama ng K, which is MA. So, that is our constant of variation. Next. The acceleration A of a moving object varies directly as the distance d it travels and inversely as the square of time t it travels. So this time we have here the combined variation, which is the combination of the direct and the inverse variation. So let's follow the condition. So the acceleration A, so yun yung unang variable. So isolate natin yon, equal to, so automatic may K tayo dyan, varies directly as the distance d. So, yung directly. So, katabi lang siya ng constant. Tapos, eto na, inversely. Tsaka tayo mag-over kapag may inversely na word as the square of the time t travels. So, t for the time. And then, may condition na square. So, lagyan lang natin ng square. In terms naman of the constant operation, cross-multiply nyo muna yung naka-isolate tsaka yung denominator. So, we have a t squared equal to, kopyahin yung kd. Tapos, divide both sides dun sa kasama ng k, which is d. So, our constant here, so cancel na yung d dito. Ang constant natin ay at squared over d. Let's have the last one. The pressure P of a gas varies directly as its temperature T and inversely as its volume. So, this is also a combined variation. So, the pressure P equal to, varies directly as its temperature. So, that is K. So, may constant ulit tayo and then T. Over, so may inversely, so doon tayo mag-over ng V. Okay, so constant na tayo. Cross-multiply yung naka-isolate tsaka yung denominator. So, we have PV equal to KT. So, para makuha yung constant, divide both sides by T. So, cancel yung T. Matitira is K equal to PV over T. So, that will be our constant. Okay, let's go over now with the applications. Start with the first one. So, mag-solve na tayo ngayon. So, in example number 1, we have, if A varies jointly as B and C and A is equal to 12, when B is equal to 9 and C is equal to 3, find C when A is equal to 6 and B is equal to 15. So, the first thing that we need to do here is to write the equation of variation. So, sundan lang natin. So, that is A equal to, so constant tayo, as B and C. So, jointly lang naman siya. So, diretso lang siya. And then, kunin natin yung constant gamit yung first value ng A, B, and C. Doon lagi sa first value. So, gagamitin natin sa pagkuha ng constant yung mga unang given. Tapos, doon sa may nawawala, yun yung gagamitin natin doon sa finding the unknown. So, we have here now K equal to A, yung naka-isolate, over BC. So, this is the constant. So, substitute natin ngayon. Ang A natin is 12. Ang B natin is 9. Ang C natin as 3. Simplify, we have 12 over 27. Tapos, get the lowest term. So, divide lang natin sa 3 parehas. So, that will become 4 over 9. So, meron na tayong constant. Pwede na natin hanapin yung C. So, ang gagawin lang naman natin, substitute natin yung may mga given. So, A tsaka B, dun sa original equation. Tapos yung K na 4 over 9. So, may A tayo, which is 6. K natin is 4 over 9. Tapos yung B natin is 15. Tapos wala tayong C. So, simplify lang natin. Pwede nating simplify itong 9 and 15. So, by dividing them by 3, so this is now 3 and then 5. Tapos, this is now 6 equal to 4 times 5 is 20 over 3C. So, to get C, divide both sides dun sa kasama niya, 20 over 3. So, cancel na yung 20 over 3. Matitira is C equal to 6 divided by 20 over 3. So, divide lang natin. C is equal to 6. Magiging multiply. Get the reciprocal 3 over 20. So, multiply nyo lang yan sa numerator. 6 times 3 is 18 over 20. So, lowest term, get the lowest term by dividing them by 2. So, 18 divided by 2 is 9. 20 divided by 2 is 10. So, the value of C here is 9 over 10. So, nag-simplify lang tayo doon. Okay, let's solve the next one. It is given that Z varies directly with Y and inversely with X. Okay, so this is an example of combined variation. So, kopya, yung unang given, yung unang variable that will be isolated equal to directly with y. So, k, y, and inversely with x. O, tsaka tayo mag-over kapag may inversely na. Okay, to get the constant formula, cross-multiply muna yung z and x. So, we have z x cx. So, may ky tayo. Cx tapos may ky. Tapos, divide both sides by y para ma-isolate itong y. Cancel na yan. So, k is equal to zx over y. Tapos, tsaka tayo mag-substitute nung first given ng zxy. So, ang z natin is 4. Ang x natin is 24 over y is 48. Ayan. Tapos, simplify 4 over 24. 4 times 24 over 48. Tapos, pwede natin i-simplify itong 24. Saka yung 48. This will be 1 na lang. Then, this one is 2. And then, 4 times 1 is 4. Divided by 2 is 2. So, ang constant natin dito is 2. Tapos, find the value of z. So, z is equal to, balik tayo dito sa equation ng variation. So, may k na tayo which is 2. Tapos, yung second value of y is 12 over x is 4. So, pwede natin simplify ito. This is 1 and this is 2. So, natira sa taas is 12 na lang divided by 2. That is 6. So, the value of z is equal to 6. So, that's how we do it. And then, let's have the last example. This is longer. The problem is longer. So, the maximum safe load of a rectangular beam varies jointly as the width and the square of the depth and inversely as the length. So, tingnan nyo dito. Ang pinagsama ay joint variation and the inverse variation. Tapos, siyempre may mga first given tayo ng width, ng depth, and then the length, and then the maximum safe load. So, ito yung gagamitin natin to find the constant. So, let's have first the equation of the variation. Sabi, the maximum safe load. So, M na lang yan. The maximum safe load isolated equal to. So, K agad tayo. Constant. Varies jointly as the width. Jointly. Width and the square of depth. So, that is D squared. And inversely, kaya tayo mag-over as the length. Okay? So, yan na yung ating equation. So, para makuha yung constant, cross-multiply ML. ML is equal to KWD squared. Copy lang. Tapos, divide both sides dun sa kasama ng K, which is WD squared. So, cancel na to. Ang constant natin ngayon ay equal to ML over WD squared. So, tsaka tayo kukuha ng constant by substitution. Ang maximum safe load natin, ang first given ay 1.6. Tapos, ang length natin ay 10. Over, the width is 2. And then, the depth is 2 also, square. Kasi may square siya dun sa formula. Simplify, 1.6 times 10 is 16 over 2 squared is 4 times 2 is 8. Then you divide, 16 divided by 8, nadi-divide naman siya. So, simplify natin as 2. So, yung constant. So, sabi dito, find the maximum safe load. So, yung M yon. Balik tayo sa equation. So, walang M equal to K. Ang K natin ay 2. Ang next is, for a beam of the same material which is 5 decimeter wide, 4 decimeter deep, and 15 decimeter long. So, ito yung gagamitin natin to find the maximum load kapag ito yung given. So, 2 which is the constant, W is the width, so that is 5. And then, the depth is 4. So, lagyan lang natin ng square. over the length, which is 15. Okay, so simplify natin ito. We can already simplify this, yung 5 tsaka yung 15. So, pwede na itong 1. Kasi ito ay 3. So, 2 na lang to. Tapos, 4 squared is 16 times 2. That is 32 over 3. Tapos, divide nyo lang yan. Hanggang hundredths tayo kasi decimal yan. So, we have 10.67 kilograms. So, ni-round up na natin to the nearest hundredths. So, this is 10 and 67 hundredths or 10.67 kilograms. So, the maximum safe load for a beam of the same distance given by the 5 decimeter wide, 4 decimeter deep, and 15 decimeter long is 10.67 kilograms. Okay, so ulit-ulitin lang natin ang video na to para masanay tayo for the joint and the combined variation. Again, thank you for listening. See you again next quarter for our lesson for the third quarter for the school year 2020-2021. Happy learning. Again, this is Sir Phil and this is Sir Phil's channel.